We'll proceed in tedious calculus problems. Okay, so mind-blowing discussion is going on. Tedious calculus problem. As always, idea is not to solve any problem. Idea is to show the way how we can tackle any problem. If I have a mathematics problem, it's not examination solution. That can you solve this by this integral? Can you solve it by that integral? If someone has a real life problem, if someone is passing through real life problem, then how he would tackle, how he would decide that I have to use calculus. Very simple answer is if someone sees it, there is division, and someone sees it, there is multiplication, then he can think of using calculus. Where he has to use calculus? Multiplication of two algebraic equation. Multiplication of two algebra. Oh, okay, where one is independent and one is dependent. What is independent? Independent is like x and dependent upon x. This is two dimensions. Like function over x. There is if someone is multiplying two items and one item is x and other item is function over x and multiplication, then integral calculus should be used rather than normal multiplication. Okay, sin x into x is not x sin x. Sin x into x is not sin x. Sin x into x is minus cos x. Can someone believe it? Okay, if someone deduce a formula where he has to get multiplication of sin x into x, and then he's writing x sin x, okay, but the result is minus cos x. Can someone believe it? Or the formula that he is getting is sin x by x, and this is what he is writing. Sin x by x is the net result, but actual result is cos x. Okay, someone is writing x square into x equal to x to the power 3, but actual result is x square into x is x to the power 3, but actual result is x to the power 3 by 3. X square by x equal to x, but actual it is 2x. This is something that hits someone's brain, someone's mind, what it is. So wherever division is going on between two algebra, where denominator is independent component and numerator is dependent component, then it is differentiation. Multiplication is going on between two entities. One entity is a function over another entity. Division between numerator, that is function over denominator. Multiplication where left side is function over right hand side. Then sin x into x becomes sin x dx. Sin x by x becomes d sin x by dx. X square by x becomes dx square by dx. X to the x square into x becomes x square into dx. So this is where we use kind of calculus. What is the story behind it is, if I just talk about the division, why it is like that is we have to understand what is called division. Division means division means change in the numerator per unit change in denominator. This is called division. Okay. Blindly people say 5 by 2 equal to 2.5, 10 by 3 equal to 3 point something, 20 by 5 equal to 4. What is 20 by 5? Okay, division means how much numerator is changing if I change denominator by 1. 20 by 5 equal to 4 means for each addition in the denominator brings 4 addition in the numerator. 20 by 5 equal to 4. Now make denominator 5 to 6, 1 change. Then you have to add 4 to the numerator. Then it will be again same. 20 by 5 is 4. Then 20 plus 4 by 5 plus 1 is same thing. 24 plus 4 by 6 plus 1 is same thing. 20 by 5 is equal to 4, then 20 minus 4 by 5 minus 1 is same thing. One change per unit change in denominator brings how many unit change in numerator? That is called division. Okay, if division brings, if division, if division brings the constant term, if 20 by 5 is 4, if it is constant, then division is all right. We don't need any kind of calculus. But if division is algebra and numerator is a function over denominator, if that is the case, it is dependent upon denominator and it is algebra, then we need differentiation rather than division. We have given example for it. Like I have given example, like I have one bag of orange and another bag of mango. Orange, number of orange in the orange is denoted as X. Number in the mango bag of the mango is denoted as function over orange, because it depends upon the number of, both are not independent to each other. Orange is independent of mango, but mango is dependent upon orange. At any moment, the number of oranges in the orange bag is X. The number of mango in the mango bag is X square any moment. Now the question is arising, what about if I add one orange in the orange bag? How many mango will change in the mango bag? Okay, then people would say, very nice, it is x square, it is x square by x. Every addition of orange in the orange bag will, someone needs to add x mango in the mango bag, where x is the current orange in the orange bag. So if orange bag has 10 orange and someone is adding one more, 10 someone need to mango to maintain the ratio, but it is not true. Someone has to add 2x. If orange is 10 and someone is adding one orange, then here someone need to add 20 or 20 mango. If the strength is 20 on the orange side and someone is adding one here, then someone has to add 40 mango there. Okay, this is called division. Division means how many change in numerator I am seeing with one unit change in denominator. If this is numeric, then no problem. If it is algebraic and numerator is function over denominator, then it is differentiation. Similarly, if there is multiplication of two items where one is function over other independent component, then it is not direct multiplication. Sin x into x, where sin x is a function over x, then sin x into x is not x sin x, it is minus cos x. Okay, this is something that drastically changes the mathematics. Drastically changing the mathematics. Anyway, I was trying to kind of calculate the, okay, I'll charge it again. I have a RC circuit. This is a this is a resistor, I believe it is very visible, 330 ohm resistor. And this is a capacitor, that is 330 microfarad capacitor. I'll try to charge it again. I should have soldered it. Every time I think I should have soldered it, I should have soldered it. Okay, I'm charging this capacitor, okay, directly from the battery. I hope it is charging. I should have soldered it. Maybe every time I think I should have soldered it. I should have. Okay, I believe it is all right. Okay, so I am holding it tightly and it is charging. Hope so. Now, if it is charging and then I have another LED, okay, I'll place it across the LED. The big leg is positive, I believe, and then it will discharge. Hope it will discharge. It will discharge through the RC circuit. So this is RC circuit, resistance and capacitor. So positive end will go here. I'll make it even far, and let's see if it really blinks. Now it should glow. Idea is it should glow because capacitor is completely charged. So capacitor is not charged. Other or this LED is not working. I'll try another LED. Every time I get to hang on this LED on. So should this LED should glow. So I'll put this positive on the positive side and I'll see if it is really glow. So either this battery is down, positive, and then negative this side. Okay, so it should charge. Idea is it should charge. Okay, idea is it should charge. I believe it is enough that it will charge to some extent. And then I'll try again to discharge through this LED. And in that sense, bigger is the positive and it should blink. Wow. Okay, so at the beginning it gave a big light and then slowly it became dim. So discharge, I'll try once again, capacitor, capacitor discharge through the LED. That is the concept. Capacitor, I'm charging it again to show it again. Capacitor is discharging through the LED. Okay, I believe it charged to some extent. And try discharging it through this LED. It should glow and then it will dim. Okay, it glue and it became dim, faded. Means this RC circuit, through RC circuit, capacitor is discharging. We were kind of trying to find the resistance of the capacitor. I always say that electronic, why we give up any science. Electronics people study and then they feel that it is very difficult. People they do not understand the resistance concept only. While people will understand transistor and diode and capacitor and so many things. So this is transistor, black color, visible. The black color, what is seen here, it is a transistor. It has three legs. Okay, internally it is dual connectivity. I'm sorry, I won't say dual connectivity of two diode. It is a dual junction diode. A simple diode is single junction, diode, double. It has one junction. Whereas if it has two junctions, then it is called triode or someone can say transistor. So that is the concept. People do not understand what's going on. Somewhere people hang up in capacitance. Somewhere people hang in current is not in phase with resistance, or I'm sorry, current is not in phase of voltage. It will go like a complex. The way these Western people, the way they have written the electronics book, anyone would run away. And China people, they tried understanding the electronics from different concept at all, and they are world leader now. So whatever, I'm not talking about electronics, whatever these Western people have written, either it is electronics, it is artificial intelligence, it is machine learning, only they can understand, or God can understand. Whatever calculus book they have written, only they can understand. Means waste, vague and west, and that's why people are suffering a lot now. The engineering what they have showed, the Western people, European or American, whatever engineering they have showed, that engineering has brought catastrophe nowadays. Now see the sea level is rising. I believe some meter it has already risen. Many islands are under the water now. If technology grow, then there should be prosperity on the earth. That is called technology. The poor people should sustain their life more easily rather than poor become poorer and rich become richer. This is not called a technology. If someone needs to go one location to another location, then unnecessarily he has to go to airport and do this much drama. When he come out of the airport from that side, he is completely discharged. His capacitor is completely discharged. Certainly, these are not called the good technology. Same is railway. Whatever you see from the Western people, all are junk. This is what I would say. I am thankful to the Chinese people who made mobile in a way that it is accessible to everyone now. Now anyone can purchase a mobile, Chinese mobile. That much they brought in technology. Whatever the equipment we are seeing here, transistor to battery to LED to register, all are Chinese made. That's why I can afford showing here. If it was made in Germany or France, this would have costed more than 2-3 thousand rupees. It was not possible probably. So technology means anyone can understand, that is called technology. Anyway, electronics is a game of resistance. When there is a battery and there is a load, that's it. If there is a red color battery, if this is the battery, this is the battery, then all right side what we are saying from positive end and then whatever is connected and coming back to negative end of the battery, that is called load. And battery, when we switch it on, when we connect the positive end of the battery to the negative end of the battery, just connect the positive end and negative end of the battery, there will be a spark. Probably that wire will get burnt out. If someone connects positive end to negative end of a battery through a thin wire, wire will become very heated, hot. It may burn also. If does not burn, your finger will burn. That is for sure. Because steep, heavy current will flow from positive end to negative end. Okay, where resistance will be zero. In that sense, heavy current would flow. Means connecting a battery from positive end to negative end, if someone is connecting, then battery sees how much is load in front of me. If there is more load, then current will be less. If there is a less load, current will be high. Okay, how much is the load? If I have connected a resistor and capacitor and LED, LED is a diode, two LED I have connected, then a switch and then back to the negative side. Now, if you read in the book, then resistor work in different fundamental. Capacitor work completely in different fundamental. LED diode works completely in different fundamental. It has a junction. One side is a kind of uh, both side of the diode is doping. One side is positive doping, one side is negative doping. One side is called positive holes and one side is negative hole or something like that. Positive more and negative more. In that sense, if someone apply voltage, then the barrier breaks down and then charge flow from the positive and negative side. Okay, anyway, then switch is there. From battery sees other side as a load, resist a block of resistance. That's it. For battery, it is not like this is capacitor and this is inductor and this is diode and this is magnetic field and this is electric field and this is complex number, this is in phase, not phase, how much angle is changed, nothing. Battery only see bat direct current and then in battery there are two types. One is direct current, constant voltage will be applied. One is called alternate current. In that sense, changing voltage will be applied, but both are same thing. In alternate current, the voltage will start rising from zero. Then one time will happen when voltage will be maximum. Then voltage will start decreasing. Consider this battery. Consider this battery is a AC battery, alternate current battery, not DC battery. Then voltage will grow, and at one moment will come when voltage will be maximum. If you take along the wire any point, then voltage will start growing or current will start growing. One moment voltage will be maximum, then voltage will come down. Okay, then voltage will start flowing in reverse direction. I mean, current will start flowing in reverse direction. Positive end of the battery will become negative, and negative end of the battery will become positive. Think in that manner. So if this if this is the battery and this is red side, one is red side, one is black side. If this is red side, this is black side, then voltage will start ramping up. And one time will come when voltage will be maximum, and then slowly voltage will come down. So current is flowing from here to here. Okay, when it becomes zero back, then current will start flowing from here to here. This is air alternate current. This is denoted by negative sign. Okay, and so this become positive and this become negative. It will switch the polarity. Okay, and then voltage will start growing from this side to this side, and current will flow in the opposite direction. One time will come when this voltage will be maximum, current will be maximum, and current will start decreasing after that voltage. Now this was positive and this was negative. It will switch the polarity again, and this will become positive and this will become negative again. That happened in beginning, and then voltage will start rising. Why it is happening like that? This is happening through energy science, because that we will see. But this is how is the alternate current, how alternate current is generated through dynamo, and why it is alternate current. Because at the dynamo, inside the copper coil, someone is rotating the magnet, but the two side of the copper coil, the current that is flowing from the copper coil, that is AC current, alternate current, alternate current. It may switch the polarity alternatively, alternatively. That's why it is alternate current. If there is a coil, then one time this is positive and this is negative. This is how voltage will come. Immediately this will become positive and this will become negative. Then immediately this will become positive and this will become negative. Why it is happening like that? Okay, that we will see. This comes in energy science. Okay, whatever it is. If I have a battery and load is there, battery see the load. Now I have a DC battery. If battery sees that either it is DC or AC, battery sees the other side as load, and depending upon the load at that moment, that much current flows through the battery. If load is zero, then infinite current will flow through the battery. If load is infinite, then no current will flow through the battery. Now, the if we are applying the RC circuit, okay, if we are applying the RC circuit, okay, that's it. If we are applying, so I don't know it is discharged or not. If it is discharged, then the LED will glow. Wow, it is glowing. Little bit this. In one day, little bit it discharge. That's it. So we can discharge it, and then if I switch it on, then this LED will glow immediately, and then slowly it will dim. This is called this capacitor charging circuit. Whereas for this, I charge it through battery first, and then put it across this LED. Then that is called discharging circuit. Whatever it is, charging or discharging from the battery. If a capacitor is connected, what is the resistor of the capacitor? That matters to the battery, not the capacitance and inductance and this and that. Battery see other end as a resistance load. At what moment what resistance would change, that is the concept of the this battery. Anyway, now here we are trying to calculate in discharge circuit what is the equation of resistance. Resistance in the sense that what is the resistance of this capacitor. Now this capacitor is completely charged with the voltage of this battery. I showed in the last session, previous video. This is 3.7 volt battery. It starts, if I charge it, it started with around 3.77 volt. Then slowly it started discharging. If it started discharging, this capacitor is behaving as a resistor. I'm sorry, this capacitor has a capacitance which is a constant item. Whereas capacitor, across the capacitor there is a charge. That charge is diminishing across the resistor, and charge is becoming like current. Charge is one energy is converting into another energy. So charge is the energy that is stored on the capacitor, and that is converting to current, another kind of energy, and it is flowing to resistor, and it is dissipating. And slowly charge will diminish, and then capacitor is discharged. Idea is at any moment what is the resistance of the capacitor? That is under the question. Anyway, at any moment, what is the voltage across the capacitor? That is Q by C. What is the charge at that moment? Charge is changeable. Every moment, charge will decrease. At the beginning, charge will be very high, and slowly charge will come down, come down, come down, come down, come down. Okay, charge by capacitance is the voltage at that time across the capacitor. So Q by C, Q by C is the net voltage that is applied across the resistor. Okay, now in that sense, equal to I is the current across the resistor, then I into R. Okay, now we apply, now if I divide it by the time, both sides, then we can see change in the charge per unit change in the current. So 1 by C into Q by T equal to R into I by T. Change in the current per unit change in the time. Okay, this Q by T become calculus because change in the charge is dependent upon at what time we are calculating the per unit change in the time. So it becomes 1 by C dq by dt, 1 by C dq by dt equal to R into di by dt. Okay, then dq by dt is I, dq by dt is the net current. Then we found that I equal to I0 e to the power minus t by RC through this calculation where I is 0 is the beginning current. I equal to I0 e to the power minus t by RC. T is at any time we are trying to calculate in discharge circuit what is the current at that time. I equal to I0 beginning current. Beginning current is beginning voltage by resistance. That is the beginning current. If beginning voltage is Vs, here it is 3.7 volt by 330 ohm. That is the beginning current. So I equal to Vs by R, capital R, into e to the power minus t by RC. We were calculating the resistance of the capacitor, and resistance is changing. That is the big thing. This proves that capacitor resistance is a variable resistance. This is a very, very big thing. There are devices in electronic system which has a variable resistance depending upon the voltage across their positive end and negative end. What is the voltage at that point? Its resistance is changing. These are called variable resistance devices like diode. Diode has positive side and negative side. If someone applies voltage to the diode, it will behave like an infinite resistance. Current will not flow at all. One moment will come when this barrier will break down and then it will behave like a zero resistance. It is like a digital circuit where resistance is either zero or resistance is one, means infinite resistance or zero resistance. This will behave like a resistance that is in two modes. One mode is infinite resistance and one mode is zero resistance. These are called variable resistor devices. This is diode. Capacitor, variable resistor divide. Inductor, inductance. If someone put inductor in parallel, inductor connected to a battery, at the beginning, since it is a coil, it will oppose the flow of the current. There won't be any current or at all. It is opposite to the capacitor, where when capacitor is connected, immediately flood of current will flow and slowly it will restrict the current to zero. Okay, initially voltage will be zero, but current will flow. If someone applies inductor across the voltage source, then there won't be any current at all. The voltage across the inductor will be maximum voltage and there won't be any current at all. It will oppose the flow of the current. But after some time, the current will start flowing through the coil and then it will start behaving like a zero resistance, means voltage will be zero and full current will flow. It will store energy. Capacitor will store energy. Diode probably when there is no current is flowing, it will store energy. After all, voltage is applied, right? These are called energy storage devices and variable resistance devices. So integrate inductor is variable resistance device. At every moment resistor would change. So resistance is dependent upon the time. Resistance like diode. If I see the diode, then resistance is not dependent upon the time. We see the diode, then resistance is not dependent upon the time. Resistance is completely dependent upon the voltage that is applied on the diode. If voltage is more than a particular threshold, then after that full time resistance is zero only, or below that full time resistance is infinite only. So anyway, there are Zener diode also that work in a reverse fact, in reverse polarity also. That That we will see. But if we see the capacitor, the resistance across the capacitor, if like capacitor is completely charged, and if I put across a resistor that has a resistance of capital R, whereas we are denoting the resistor of the capacitor as small r resistance of the capacitor, and capital R through which we have connected this charged capacitor. Now, in that sense, resistor value of the capacitor will change. At the beginning, resistor will be different. At the end, when it is completely discharged, at that moment, resistor will be different. So, resistor is dependent upon time. Okay, or someone can say resistance is also dependent upon the voltage across the capacitor. Voltage is slowly it is dimming, but voltage is dependent upon the time. So this proves that resistor is more or less is dependent upon the time. What it is, that is we are calculating. Now current in the RC discharge circuit at any moment equal to I0 e to the power minus T by RC. That is the current. Okay, if I multiply this current with the internal resistance of the capacitor, that is the voltage across the capacitor. Voltage across the capacitor at any moment is Q by C. How much charge it contains? So Q by C equal to small r into I. I is same in the discharge circuit too. So Q by C equal to small r I0 e to the power minus T by RC. If that is the case, then R equal to Q by C into 1 by I0. I0 is a fixed value. That is voltage at the beginning of the capacitor divided by the resistance of the resistor, capital R. I'll denote it as I0 only. That is 3.7 by 330 ohm. Now we have internal resistance of capacitor equal to Q by C into 1 by I0 into e to the power T by RC. Now, this is the function we deduce the formula of resistor. When time equal to 0, then e to the power T by RC is 1. Now, in that sense, what is the resistance? That is Q by C into 1 by I0. Now, I0 is constant, C is constant, charge. If charge is very high at the beginning, there will be maximum charge on the voltage. Means at that moment when t equal to 0, when time is 0, at that moment the resistance of the capacitor is directly dependent upon the charge. Charge is maximum at that point. This means that when capacitor is charged, completely charged, resistance is maximum at that point. These are not mentioned in any of the book. Go and check. What is the how we calculate the internal? Because this is the resistance. What if I connect? We will see from the charging circuit also. This is the resistance what battery is seeing when it is connected to RC circuit. What is the resistance of the net load? Add the resistance of the resistor and add the resistance of the capacitor. What is the resistance at that time? That much current will flow. That's it. Simple. Okay. So resistance when in the discharge circuit, when charge is maximum, resistance is maximum of the capacitor. In charging circuit, what is the equation? In charging circuit, the equation is I equal to I0 e to the power minus T by RC. Same thing is there in charging circuit also. Same equation. In that sense, same formula will come. Resistance equal to Q by C into 1 by I0 e to the power T by RC, not minus T by R, e to the power T by RC. In that sense, when time equal to 0, in charging circuit, internal resistance equal to the Q by C into 1 by I0, the beginning current, and beginning current is the voltage of the battery by the resistor in the RC circuit, whatever it is. But charge at the beginning in the charging circuit is 0. Means when at that time capacitor is completely discharged, at that moment resistance is 0. So if I have a capacitor that is completely discharged, then its internal resistance is 0. If I connect it through a battery, then it will show 0 resistance. Means whatever is the resistor in RC circuit 330 ohm, that will come into the picture. and current will flow as if only this register is connected to the battery. That's it. These are called real life calculus. And then resistance here will be 0, because resistor equal to Q by C into 1 by I0, that is the beginning current, e to the power T by RC. As we pass on the time, then charge will be more. We will see what is the charge as per dependent upon the time. Then charge will start developing on the capacitor plate. Charge will grow, and e to the power T by RC, R is constant, C is constant. T will start growing. In that sense, resistor of the capacitor is directly proportional to the charge it is storing, and it is directly proportional to the e to the power time. Okay, means resistance of the capacitor is growing exponentially. E to the power T by RC. Consider R is 1, capacitance is 1. Then e to the power T. Then as T is growing, e to the power T, exponential to the power T, means if T is growing, this mathematical part will grow exponentially. Then charge by C. Leave the C. 1 by I0. Leave the I0. I0 is 1. C is 1. Charge into e to the power T. If charge is the way charge is growing, resistor will grow into the way time is growing, exponential of the time, means resistor will grow more than exponential of the battery, of the capacitor in charging circuit. In discharging circuit, same way, e to the power T by RC. If time is growing, then resistance would grow exponentially, but charge is decreasing. So one moment charge will be 0. Whatever e to the power T you take does not make any sense. So resistance, see the funny way, in discharge circuit, resistor is directly proportional to the charge. But charge is going down. Okay, and resistor is directly proportional e to the power T. E to the power T is growing. In that sense, charge is decreasing, e to the power T is growing. It will make a funny curve of resistance. No one has drawn resistance, I believe so. Someone can draw it, and one time will come when charge will start coming to 0, and that moment resistance will be 0. At the end, in discharging circuit, resistance at the beginning will be driven by charge, and at the end, since charge is 0, it will become 0. What is the equation of the charge? Okay, in discharging circuit, we have a formula. The voltage across capacitor is same as voltage across the resistor. Okay, in that sense, Q by C equal to R into I. I is dQ by dt. Okay, that is the current that is flowing through the capacitor. Q by C equal to R dQ by dt. Okay, in that sense, it becomes 1 by RC. 1 by RC into Q equal to dQ by dt. dt by RC equal to dQ by Q. In that sense, big dq by q is ln q, natural log of the q. Beginning from beginning charge to end charge. Beginning charge, at the beginning charge, consider charge is q. Beginning charge, consider the charge is q0, and end at any moment q0 to q. Then it becomes ln q by q0 e to the power t by rc. Okay, dq by dt, beginning charge is q0, and at any moment what is the charge? Ln q by q0. Okay, equal to, now we have dq by dt. Okay, we were considering dq by dt. We will take negative because charge is decreasing. Now in that sense, q by q0 equal to e to the power minus t by rc. Q equal to q0 e to the power minus t by rc. So at the beginning, whatever is the charge is, then charge will start dropping in exponential function as e to the power minus t by rc. Someone can substitute what resistance formula we had drawn. Okay, that resistance formula was Q by C into 1 by I0. Q is Q0 at the beginning, whatever the charge is. Q0 e to the power minus T by RC by C by 1 by I0. Take C Q0 away. Then it is now Q0 also away. E to the power minus T by RC. and e to the power t by RC. Now it will become e to the power 0. Okay, something like that. Someone can do in this fashion how much it is, whatever it is. Now it is the people, I'll also try, but this is how it is. So someone can think about the variable resistance of the capacitor in the charging circuit and discharging circuit. Okay, we probably will take one more session on this and then we'll proceed in the tedious calculus problem. Please don't mind supporting us. +91 is the India country code. 9483160610. 9 plus 91 is the India country code.